Like whenever somebody starts watching the video.
Okay, so today's lesson is just a continuation of this module that we've been doing. Lesson 7 is called Identifying Proportional and Non-Proportional Relationships in Graphs. Actually, that's not the name of it. It's called Unit Rate as the Constant of Proportionality. I must have forgotten to change this. It's Unit Rate as the Constant of Proportionality. And if we look at the standard, our goal for today is being able to identify the constant of proportionality in tables, graphs, equations, diagrams, and verbal descriptions of proportional relationships. We've already been doing this. When we found that magic number that you multiply in tables, I told you at one point that its name was the constant of proportionality, but today is when we emphasize that and we start to learn what that word constant of proportionality means. Okay, so to start with, we have a hypothetical question here. Let's read this example together. Example 1, National Forest deer population in danger. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. Scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. Do conservationists need to be worried? So we're going to go all the way through all of these questions, A through D, and then at the end we'll be able to answer that question of whether conservationists need to be worried. Before we go any further with this, what is a square mile? It's pretty important that we know what a square mile is. Kate?
It's 1 mile by 1 mile.
Okay, so it's a square that would be 1 mile by 1 mile. So a square mile, let's just draw a small version of a square mile, is a square area of land that is 1 mile on either side. So when we're talking about 16 square miles, we're talking about a large square area made up of 16 square miles. So that would look something like this. So where there are 16 of these square miles. So it's not a 16 square mile area of land is not 16 miles on each side. It's only 4 miles on each side because when we multiply 4 times 4 to get the area, we get 16. So that's what that's talking about. So what I want you to do is take a couple minutes and discuss this with your partner. Just get as far as you can, questions A through D. We'll spend about maybe 5 minutes on discussing, and then we'll come back together and talk about it. Okay, I forgot to start the button on the recording, so we're coming into this a little late. So those of you watching the recording, just to review, when you're finding how many deer per square mile, you just take the number of deer divided by the square miles. So 144 divided by 16 gives us 9. So does 117 divided by 13. That gives us a unit rate of deer per square mile of 9. Unit rate is the same as the constant of proportionality, so it is also 9. Okay, and the question that I just asked, Connor with an O, is this a proportional relationship?
Yes.
Yes, what makes it a proportional relationship?
Because you can multiply the numbers there by 9.
Okay, multiply which numbers? Let's get really specific.
16, 13, and 24 to get 144.
Okay,
17.
good. So we can multiply anything on the left side of the table, which is our x, by 9 to give us y. So you can write times 9 at the top of the table if you made a table. It just shows that that's our magic number, or that's our constant of proportionality. Okay, then it asks you to explain the meaning of the constant of proportionality in this problem. So this is saying, when we find 9, what does that mean? How can we say that in words? I'll take a volunteer on that one because I'm not sure if you understand what we're looking for with that. Anybody want to say, what does 9 mean? Okay, I'm going to tell you on this one. I don't know if I have it on the next screen or not. Board's freezing a little bit. Okay, there we go. Explain the meaning of the constant of proportionality. This will come up in quizzes and tests, so this is important. The 9 just means that there are 9 deer for every 1 square mile of forest. For every 1 So as I said a minute ago, the constant of proportionality is the same as the unit rate, but we have to know what are we talking about. We're talking about what quantity for one of what other quantity. And in this case, there are 9 deer. That's our first quantity for every 1 square mile. That's our unit. Okay, then part C asks us to use the unit rate of deer per square mile, and it reminds you how you find that by doing y divided by x to determine how many deer there are for every 207 square miles. So if we go back to our table, my board is really slow today, and we put 207 in for square miles, we want to find out how many deer would there be for 207 square miles. So I will give you just about a minute to find the answer to that if you have not done so already. And then part D asks, use the unit rate to determine the number of square miles in which you would find 486 deer. So if the number over here was 486, what would X be? Okay, so let's answer the first question. Ava, how many deer are there in 207 square miles?
I think it was 207 square miles, deer.
Oh no, 207 square miles, how many deer? Another volunteer for that. Carly?
1,863.
Good, 1,863. And Carly, how did you get that number?
I know by 207 by 9.
Good, that's our rule in the table. If we multiply X by 9, we get Y. So if we multiply 207 times 9, we get 1,863. Volunteer for the number of square miles in which you would find 486 deer. Charlie.
54 miles.
And can you tell us what you did to get 54?
I divided 486 by 9 and got 54.
Okay, so when we're going from right to left on the table, we need to do division. We need to do the opposite of multiplication, so that now that we have this 54, we could do 54 times 9 to give us 486. Okay, any questions about that? Let's go back to the original question. Do conservationists need to be worried about the deer population? Kate? No, why not?
Because it's all equally spread out.
Yeah, it's equally spread out, or it's constant all throughout. Now, if you were to actually do a count of deer, this is probably not going to happen, that you end up with the exact same number every time, because nature doesn't usually work out that way. So you would be looking to see, are the numbers close? If they're really far away, like one area gave 3 deer per square mile and another area gave 25 deer per square mile, you would want to wonder why they were so far apart. But sometimes when they give us math problems, they simplify things a little bit to make the numbers work out. So that's how we ended up with 9. But in reality, we probably end up with numbers that were slightly different. Okay, so we did not write this down, but we talked through these. Let me just add these up here. This, you would do 207 times 9 to get 1,863. And this, you would do 486 divided by 9 to get 54. Okay, the next segment, there's some vocabulary up at the top of the page. It just talks about what a variable is. Let's just review that briefly. A variable is a symbol that is a placeholder for a number. So when we write that equation, y equals kx, the x and the y stand for the numbers that are in the table. For any numbers that would make the equation true. K is that new thing that we talked about, the constant of proportionality. Okay, we're going to go on where it says example 2. You need what? That's what I might say to my kids if this happened to me. Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needs 3 cookies for each of the 96 students in 7th grade. How many of you would your mother or father be kind of irritated with you if you came home and said that you volunteered to make cookies for your entire grade? I would be. I would be like, oh my gosh, we don't have the ingredients. We're going to have to go to the store. It's going to take all night. Anyhow, so it would be kind of annoying. So he did this to his mother. And unfortunately, he needs the cookies the very next day. Brandon and his mother determined that they can fit 36 cookies on 2 cookie sheets. So part A asks us if the number of cookies is proportional to the number of cookie sheets used in baking. Create a table that shows data for the number of sheets needed for the total number of cookies baked. So I have a table up here. I'm going to recommend that you put the number, and I'm going to use this sign, which doesn't just mean hashtag, it means number. That's what it meant way back when. It didn't used to mean hashtag. Number of sheets. If you want to specifically say cookie sheets, you can. And over here, number of cookies. Okay, so I'm going to give you some time to discuss this in your group. You can choose whatever numbers you want to use here. I would recommend that you start with what he talked about here, that 36 cookies fit on 2 cookie sheets. So that should be the first thing that goes in your table. You may use whatever numbers you want for the rest of it. So discuss A and B. All right, Connor with an E. Tell me how you filled out the table.
I filled out the table for a number of sheets of like 2, 4, 6, and 8.
Okay, so you used every other even number, okay?
And then for the number of cookies, so about 36, 72, 108, and 44.
Okay, so then the unit rate of y over x. Maddie, what did you get for that?
18.
18. Good. And can you tell us how you got that?
I divided the number of cookies by the number of sheets.
Good. Number of cookies divided by number of sheets. So number of sheets would be our x. Number of cookies would be our y in the table. Chris, what's the constant of proportionality?
18.
18. Good. So we can say k equals 18, or you can just write 18. You don't necessarily have to have the k there. Okay, explain the meaning of the constant of proportionality in this problem, keeping in mind how we explained it for the last problem. Charlie, how would you explain the constant of proportionality? What does 18 mean?
So 18, 18 number of sheets.
Is there 18 sheets? Is that what the 18 stands for? 18 is going to stand for the number of something compared to one something else.
I don't know.
Okay, let's get a little help from Allie.
18 means the number of cookies per sheet.
Okay, so there are 18 cookies per cookie sheet. There are 18 cookies per sheet. Okay, part B is kind of an interesting question. It takes 2 hours to bake 8 sheets of cookies. If Brandon and his mother begin baking at 4 o'clock p.m., when will they finish baking the cookies? And you come up with this answer. Let's see, anybody else? Okay, Maddie, I think you want to go first.
8 p.m.
8 p.m. Good, good, that is correct, 8 p.m. Let's talk through that because I think not everybody quite got to that. So Maddie, can you explain the process behind what you did?
Well, if you have 3 cookies for every student, we first have to multiply 96 times 3.
Okay, so you need to know how many cookies you need altogether. Let me see if I have that on a separate page. Wow, this is slow today. Usually I hit that button and it's just there. Okay, so we need to know how many cookies does he need. So you have to use that as a different unit rate of 3 cookies per person times 96 people gives us 288 cookies. Okay?
Then you need to figure out how many cookies you'll have with 8 sheets of cookies.
Okay, how many cookies you'll have with, okay, so how many cookies would you have?
144.
144. So 8 sheets of cookies. And what did you do to find that out? What did you do with the 8?
Divided by 18.
Because we know that 18 cookies fits on one sheet. Would give us a total of, what did you say? 144? 144 cookies. So every 2 hours, they're going to be able to make 144 cookies. Therefore, it's going to take how much total time?
4 hours.
4 hours, because 144 times 2 is 288, so we're just doubling the amount of time. So it's going to take 4 hours. See, that's a lot of time making cookies. That's why I don't like to make cookies, because it takes so much time to wait for each batch. You know, if you make a cake, you put it in and it's done. It will take 4 hours, so they will finish at 8 p.m. That was a great multi-step problem. Any questions about that? Okay, last thing we're going to do is example 3, French class cooking. So let's read through this together. Suzette and Margot want to prepare crepes for all of the students in their French class. How many of you have had crepes before? A few of you? Have you made them?
Yeah, I think we made them in one of our classes.
Oh, did you really?
Well, I did.
Crepes, yeah. Crepes are like a really, really thin pancake, and you can like roll things up in them.
Oh, we made it.
My kids make crepes every so often on Saturdays, and we put berries in them, or chocolate, or marshmallow fluff, or whatever we have around. So they're just like a flat pancake that you can roll up. A recipe makes 20 crepes with a certain amount of flour. So they don't tell us how much flour, it's just a certain amount of flour, milk, and 2 eggs. The girls already know that they have plenty of flour and milk to make 50 crepes, but they need to determine the number of eggs they will need for the recipe, because they are not sure they have enough. So part A says, considering the amount of eggs necessary to make the crepes, what is the constant of proportionality? Now, you can think about this either way. If you were to set up a table, you might put eggs on the left, crepes on the right. That's probably how I would do it, because the amount of crepes that you would make would depend on how many eggs you had. You could technically look at it the other way and say that the amount of eggs you need depends on how many crepes you make. But just to keep this consistent, let's say that if we did an XY table, that eggs would be our X, crepes would be our Y. So when you're finding the constant of proportionality, we'll all get the same constant. Okay, so questions A, B, and C shouldn't take too long. This is not as complicated as our last problem, so we'll take a couple minutes and then we'll talk about this.
You call it 11 for 16.
For part A, Emily, what is the constant of proportionality?
1 egg per 10 crepes.
Okay, and when they're asking for the constant, all we need is the actual number. So thanks for providing the words, because that gives us even more clarification. That's more what we're going to do in part B. So the constant of proportionality, we could just say K equals 10. Okay, then in part B, we're explaining that using words. Haley, what does the constant of proportionality mean in the context of the problem?
There are 5 eggs per 50 crepes.
Well, we want to use the number 10 in that sentence. So your sentence is true, but it's not explaining the constant of proportionality itself. Ellie?
There is 1 egg for every 10 crepes.
Okay, there is 1 egg for every 10 crepes. There should be some kind of little accent there, one of these little things, but I don't know what they're called. Okay, part C, how many eggs are needed to make 50 crepes? Bella? 5 eggs, good. And I saw as I was walking around, a lot of you were completing the table. The most common thing I saw was 2 eggs, 20 crepes, 4 eggs, 40 crepes, and then a lot of people just jumped right to 5 instead of going up to 6. You stopped at 5, so you did 5 eggs for 50 crepes. Okay. Any questions about any of that? Okay. We are going to do an exit ticket on today's lesson, but we will do that after you get back from the bell. That way, everyone can take the break. For your homework is going to be problem set 7. So it's on the back side of your notes, and it's all 4 problems. Some have multiple parts.